Alright, and now we're going to work through some examples using Prism. So, example 1 says, find the volume of a cube given that its space diagonal length is 6. So, I'm going to take it a different approach, actually constructing a cube and drawing this all out. Now, your book has a nice, neat formula for the space diagonal length of a cube. I'm not going to use that. You can also check your answer by that method. But what I want to do first is, with any of these problems, get a good picture drawn. Okay, and again, it's not going to be perfect. This is for my own reference, so if it's not perfect, it's fine. But to make a cube, I'm going to do my best to draw a cube. Okay, here is the front. My top of the cube is going to look something like that. Side is like that, and then I have to extend down, extend back, extend over, so it looks like the back of my base is going to look something like that. Okay, so there's my cube. And now what I know is that a space diagonal is, so maybe from this vertex down to this vertex here, is 6. Okay, we can actually show, and this I'll leave up to you, but we can actually show that all space diagonals are the same length in a prism. If we have a right rectangular, or if we have a right prism, all the space diagonals will be of the same length. Okay, so now what I want to do is I want to try and visualize this by putting it on a single plane. So that plane would involve these two vertices and this other vertex. So if I look at this, okay, I know, let's see, okay, this is going to be a right angle. Now all the sides of a cube have the same length. And so if I now just look at the top surface here, if I know this is S, this is S, this length here should be S square root 2. Okay, so now what I'm going to do is I'm going to come over here and make a different diagram. So I have, that should be, let's just erase that and start over. So I want a vertical line, and here's the other leg of the triangle, and there's the hypotenuse. So that's the right angle. I know that this side length is S, this side length is S square root 2, or sorry, yes. And then this side length is going to be 6. So I can determine the value of S using the Pythagorean theorem. So 6 squared is equal to S squared plus 2s squared. Okay, that's what you get when you square that. And so then this is going to be 36 is equal to 3s squared, so 12 is equal to s squared, and then 2 square root 3 is going to equal s. Okay, and then from there, the volume, we can just use the fact that volume for a cube is side cubed, so this is going to be 2 radical 3 cubed, and when you do this, I got 24 radical 3. Okay, so again, you could have probably saved yourself a lot of time by just using the formula in the book, but this is really where the formula came from. So I wanted to show you how to set up a picture, how to draw in 3 dimensions, and then take the 3 dimensions and compress it down into 2 dimensions, which we already know. Okay, generally that's a very good approach in these problems. Okay, now example 2. So we know that ABCDGF, or EFGH, yeah, that thing, is a right rectangular prism. Alright, so all these angles are 90 degrees, and we also know that the vertices up here all measure 90. And so if we know that AB is 4, so I'm going to start labeling this stuff. AB is 4. BC is 3. And ABGH is a square, find all these different things. Okay, so the first thing, BD, I don't think that actually depends on this fact that ABGH is a square. That might come in later. So let's see, I want to find BD, right? So, well, opposite sides of a rectangle are congruent, so this would be 3, and this would be 4. And I know that this is a 90-degree angle. So we studied Pythagorean triples, 3, 4, 5. Okay, so this one is just 5. So I know that that is 5. Alright, and now AG. Okay, this could be a little challenging. So I'm going to attempt to draw this A to G. Let's try that again. Alright, undo that. So I want to start at G, and I want to go to A. Okay, it's supposed to be a straight line. You'll forgive my drawings. Now, this is a little hard to visualize. So again, this is going to be a space diagonal, which I can find. But again, I just want to make sure I know what's going on here. So if I know that, I can either use, so there's two approaches. One, I can use the formula for the space diagonal of a right prism. Okay, to do that, I would need to know what side length CG is, or similarly any of the other sides, so I know the height. Okay, in absence of that, though, I can say, well, I know that BG is going to lie on the same plane, and as well as AH. So really what I'm doing for this one is I'm saying, okay, well, I know I have, this is a square. Well, we'll get there, I guess. So A, let's try that again. It would be B and then A. So this would be B. This is A. And then G would be down here, and H would be here. And what I'm looking for is AG. Okay, because that would all lie on the same plane. Now, this is where this bit of information that we haven't used yet comes into play. ABGH is a square. So I know that this side length is 4, so then this would be 4, this would be 4, this would be 4, and I also know that because it's square, it's a right angle, so then that tells me that this is going to be 4 square root 2. So AG is going to be 4 square root 2. Now again, this is using a two-dimensional approach where we visualize it in 3 dimensions and then compress it down into 2 dimensions. Very handy way of looking at these problems. Alright. Okay, then part C says to find FD. Okay, well, that's another space diagonal. I'm going to leave it up to you to prove what I mentioned earlier, but in a right prism, all the space diagonals are of equal length. So this should actually be 4 square root 2 as well. Another way that you could prove this is by using the formula. So this would be, you could also do the square root of length squared plus width squared plus height squared. And to get that height, we can actually do that right now. This is the only missing component. But from this diagram, I know that BG was 4, right? This was length 4. This was length 4. I also know that BC is 3. And then we know that the bases are parallel and congruent, so this would be 3. And to determine this height, h, I can say, well, 4 squared should equal h squared plus 3 squared. And so after solving this, I would actually get that h is the square root of 7. And then as a result, I can plug this all in here and I'd get the same thing. Okay. And then the last part says determine the volume. Well, volume is, let me just come down here a little ways. Volume is length times width times height in a prism. So what I need to do, and again, that would be length times width is the area of the base, and then the height is however high the prism is. So we determine that the area of the base would be 3 times 4, and then the height would be square root 7. So this is 12 square root 7. And then remember, if there's given units here, this would be units cubed.